Your friend has an LR circuit with a 10-volt battery and tells you that 2 seconds after closing the circuit, the current is 0.5 amps. Your friend also tells you that after a very long time has passed, the current is 4 amps. Determine the resistance and the inductance. Okay, so let's start with this opening statement that tells us we have a 10-volt battery. And additionally, it tells us that after a very long time has passed, the current is 4 amps. Now, remember that in an LR circuit, the current behaves asymptotically. So that means after a very long time has passed, we expect the current to essentially be at the max current. So that tells me that this 4 amps is the max current. We have this formula that relates the max current to the voltage of the battery and, of course, to the resistance. So we can easily solve for resistance. R is going to equal V naught over I max. Yeah. So I know what V naught is. That's 10. Oops. So I've got 10 volts divided by I max, which is 4 amps. And so that means that R is going to equal 2.5 ohms. So there's my resistance. Now I need to find out what the inductance is. Okay, to do that, the only formula we have for inductance is this one, which deals with the time constant. This is the only formula we have in the LR circuit that deals with inductance. So we need to find the time constant, which means we're going to use this formula. We're going to use this one and solve for tau. Okay, so I know the current, that's 0.5. I know the max current is 4. 1 minus e to the negative t. This half an amp occurred 2 seconds after it closed. That's negative 2 over tau. Okay, so this becomes, let's see, this is going to be 0.5 divided by 4 is 0.125. And now bring the e over. This is e to the negative 2 over tau. And at the same time, I'm bringing the 0.125, bringing this over to the other side, subtracting it from the 1. So that's going to be 0.875. Take the natural log of both sides. If I do that, all I get on the left side is the power, negative 2 over tau. And this is the natural log of 0.875. I'm solving for tau, so this is going to be negative 2 over the natural log of 0.875. That's going to equal tau. And so now just use my calculator. And I get approximately 14.98 seconds is tau. Okay, so now I know tau, and I know the resistance, so I can easily solve for L. So let's do that. Switch colors one more time. So tau equals L over R. Tau is approximately 14.98. R is 2.5. And so what I get is that the inductance is approximately 37.44 henries.